In this video, we'll be taking up the second homework sheet on exponential equations. So for the first question, you're solving 4 exponential equations. Now, for 1a, b, and d, really think about converting to logarithmic form, because converting to logarithmic form will help you solve for the exponent if that's where your variable is located. And that is the case for 1a, b, and d. So I basically applied the same strategy using logarithmic form to help me solve for the variable. Now for b and d, there's an extra step because you have to divide both sides by 1.5 before you change it to logarithmic form. For 1c, you didn't have to use logarithmic form. You could have, but I chose to equate set these two powers to have the same base, because 4 and 1 over 8 can both be expressed as powers of base 2. So that's what I did. But you could have used logarithmic form. Okay, so for question 2, you have a relationship between the amplitude and time. So they gave me the time in 2a, so I solved for the amplitude. And for b, they gave me the amplitude, and I solved for the time. Not much to say there. But c is interesting. There are lots of different ways to do c, but I chose to do it the way I have here. And this is very elegant because it relates us, it's analogous to the idea of half-life. So I solve for the amount of time it takes for the amplitude to be half of the original amount. So that's why it goes from a base of 0.65 to a base of 1/2. So after I do the math, after I change the base to 1/2, I'm able to tell you that the amplitude, the time it takes for the amplitude to be half of the original amount will be 96.5 seconds. And then you can answer the question and determine that it will 15% of the original will not be double of 168 seconds, because the time I solved for earlier is 96.5. Okay, so for question 3, this is one of my favorite questions because the way I do it is much shorter than the textbook way. You don't need to use logarithms. You could if you want. So the way the textbook does it is take the logarithm of both sides. So that's why their answer, the answer key is a little different, because I think they did it the way the textbook did it. So if you're doubtful that my answer is different than the textbook's answer, you can just punch it in the calculator and you'll notice that they look exactly the same. Now, saying that, which answer is better? I would argue this one is better, because if I can express it as a single logarithm, why not? Why would I want to express it the way the answer key shows it? It's so much more clunkier. Yeah, that's the best word I can think of. This answer is very elegant, very straightforward, and the number of steps required to get there is minimal. So 3b is very much the same as 3a, basically the same strategy. Just really make use of your exponent laws from grade 9. Okay, question 4. Basically, you have a quadratic. Even though it's an exponential equation, change it to a quadratic equation. Quadratic formula because it's not factorable, and then solve for x using logarithmic form. Now I wrote it as 2 separate lines, but you could have condensed this to one line and just say x equals log base 3 of 2 plus or minus root 3. Okay, question 5. It's a half-life question. They want me to solve for the half-life. So yeah, not much to say. Just solve for the half-life. 5b, the graphs aren't very pretty, but you can graph it on a nice piece of grid paper. It's basically your first graph is your exponential decay graph. Now the 2 other graphs, you can determine them by using transformations of your original exponential decay graph. So for the first graph, it asks you what if it's the same half-life as francium, but the original amount was 30 milligrams instead of 25. You can get that graph by vertically stretching the original graph by a factor of 6/5. Now where did I get 6/5 from? Because 25 times 6/5 is 30. So all the y values are multiplied by 6/5 to get this new graph. And the next graph, I can obtain it by horizontally stretching by a factor of 2. Now, why did I say horizontal stretch by a factor of 2? Because the half-life is twice as long. So it makes perfect sense to apply this transformation to get the new graph. Okay, this is question 6. Question 6 is just quadratic. Now, for 6b, you have to multiply both sides by 2 to the x to get your quadratic first. And for 6c, it's a little different because you have to use a quadratic formula. But really, they're the twist on the same question. It's just quadratic equation. Okay, you change your exponential equation into a quadratic equation and just solve that quadratic equation like in grade 10. Be careful here. 3 to the x equals -3 or 2 to the x equals -1. You can't get roots, or you can't get solutions from these equations because 3 to the x or 2 to the x is strictly positive. Okay, question 7. You have a relationship between time and population, I believe. Yes, time and population. So if I give you the population, you can solve for the time. These are very reminiscent of what you did in grade 11. Now in grade 11, most of the time we give you time and you solve for population. So now you have to go the other way around. Now it's hard to give you this question in grade 11 because you didn't know about logarithms. But now that you have that skill set, you can easily solve for time. 7b is just a twist on 7a. You're solving for a very specific time, which is a doubling time, the time it takes to double the population. Question 8, you have a relationship between the number of bounces and the height of the ball. Nothing much to say, but I want to add here for 8b, you have to round up because you want it to be less than 0.1. So even though it's 0.4, you have to round up to 29 to get less than 0.1. For question 9, really it's just quadratic again. By looking at the powers, you can change them all to a base of 2 and then break up 2 to the power of x plus 2 to be 2 to the x times 2 squared to create that quadratic equation. Okay, for question 10, we have a base of 1.4 and they want us to change it to a base of 2. And I believe in the answer key, they approximate this value, the exponent, but you definitely don't have to do that. This is a beautiful answer as is. We accomplished what the question asked us to do. They want a base of 2, we gave them a base of 2. Okay, so for 11a, they want us to solve for the yearly growth rate. So that's why it's just 6 here, okay? You can think of it as 6 over 1 for the yearly growth rate. But for 11b, they want us growth rate per decade. That's why it's 6 over 10. 6 over 10. And that makes sense because 6 years is 60% of a decade. So it makes perfect sense for the exponent to be 6 over 10 or 0.6. If you do the math, you get a whopping 360.5% growth rate per decade. That is very, very large. Okay, so that's it for the second homework sheet on exponential equations. Hopefully it wasn't too bad.